In this video, we are going to talk about what is p-value, how hypothesis test using in traditional and p-value method. I have to apply these concepts onto the cardio good fitness dataset. So let's work on this problem as an example. The assumption value of all customers' average age is 30. We have the 180 individual sample average age is 28.78. The standard deviations is 6.943. Here the average age of all the customers is 30. So mu is 30. Now they believe the answer to be different, so the alternative hypothesis is that the mean is not 30. Now let's move on part 2, at a 95 confidence level. Is there enough evidence to discard the null hypothesis? Now we use both traditional and p-value method. We know that the sample size n is 180. The average age of 180 individual sample mean x bar is 28.788. The sample standard deviations s is 6.943. In this problem, we don't know the population standard deviations. The next thing is significance level. We have the confidence level is 95%, so it's 0.95. This significance level represent by alpha is equal to 1 minus confidence level. Now the alpha value is 0.05. Now the p-value method. In p-value method, we need to calculate p-value, which represents the area that corresponds to the z or t test. If p-value less than alpha, we are going to reject the null hypothesis. If p-value is equal to or greater than alpha, we not reject the null hypothesis. So we should accept it. Usually the null hypothesis is called the assumption hypothesis. An alternate hypothesis is the research hypothesis. This is the p-value method. For the traditional method, we need to compare the calculated z-value with the z-value that's associated with the test statistic. Here we are dealing with one-tail test or two-tail test. The mean doesn't equal to certain number for the alternative hypothesis, we are going to have a two-tail test. Here I am going to create graph. This is the 95% of confidence level. So we need to determine the z-value corresponds to that. This is alpha value, which is half of 0.05, and on the left this also that's 0.025 with the same area value. To get a z-value that corresponds to 95% confidence level, we need to use the z-table.a and the z-table that I am going to use in cumulative area function. Here I have mentioned the total area that is going to be sum of 0.25 and 0.95, so the cumulative area from the left is 0.975. Now we are going to find the z-value that corresponds to total area. Here we have a positive z-score table and we have a cumulative area to the left of 0.975.so, we need to locate that in the table. This corresponds 0.975 to a row with a value of 1.9. And the column is 0.06. So, an area value of 0.975 corresponds to a z-score of 1.9 plus 0.06 or 1.96. These z-values are known as critical values. Due to symmetry, the other z-value on the left is going to be negative 1.96. Based on the traditional method, we need to compare these critical values with the calculated z-value that we are going to get from test statistic. Now, which test method we have to use for this problem? If the standard deviation is known, a z-test is employed, and if the standard deviation is unknown, a t-test is used. Some courses, due to central limit theorem, whenever the sample size is larger at least 30, apply the z-test. Whether the standard deviation is known or not, for this data, we will conduct z-test. Because the standard deviation is known, we could use the z-values. So, the formula that we are going to use to get our calculated z-value will be the sample mean, minus the mean of the null hypothesis divided by the sample standard deviation over the square root of n. Here, we could apply the value of this formula. After solve this calculation, we are getting the value of calculated z is minus 2.3 for 4. Now need to know where the z values falls in this area. The region that is not shaded, that is fail to reject region. the red area that is shaded, that's rejected region. Our Z value is minus 2.3 for fur is somewhere in the rejection region. Then we compare the critical value and the calculated Z value. Our calculated Z value is greater than our critical value. Thus this tells us that we need to reject the null hypothesis. This is the traditional method. Now let's p-value method. I am going to mention the calculated Z value on the normal distribution. Now what we need to determine is the area of the shaded region, that total area the left side and right side, that's going to correspond to our p-value. Then compare this p-value with alpha. We are going to use same table and get the area. In this Z-score table, need to find a row with a value of 2.3 and the column with the value of 0.01, because our Z-score 2.3 for 4, the area value intersects that row and column, as we can see here 0.98956. This is the area value that we want to use correspond to a Z-score of 2.3 for 4. So, that area value is the sum of left side rejection area and fail to rejection area. To calculate this right area, it is going to be 1 minus 0.98956. So, this point is 0.01044. Left side it's going to be same. In middle, it's 0.97912. Now the p-value is the sum of the area highlighted in red on the left side and right side. It's 0.0208. Now, we compare the p-value with alpha 0.05. Here, our p-value is less than alpha, so we need to reject the null hypothesis. This is the p-value method. The statement is that with a 95% level of confidence, we cannot accept the null hypothesis. Same analysis I have done by using the Python programming language. I have found the mean of age, p-value, and standard deviations from the cardio good fitness dataset.